Somewhere in a test facility outside Shanghai, an engine core spins up to a speed that would have been unthinkable for a Chinese-built jet engine a decade ago. It's mounted to a rig, not a wing, surrounded by sensors, and by the time the readout settles, the number on the screen is one that starts getting quietly passed around aviation circles online before it ever makes an official press release: 35 tons of thrust. That's not a number chasing a regional jet or even a narrow-body airliner. That's a number that belongs in the same conversation as the engines hanging off a Boeing 787 or an early Airbus A330. And it didn't come from Rolls-Royce, GE, or Pratt & Whitney. It came from China. That engine is one piece of a much bigger puzzle that China has been assembling patiently for almost 2 decades. And the final piece of that puzzle has a name that's been circulating through Chinese aviation forums and industry chatter for a while now: the COMAC C939, a wide-body aircraft designed to sit in the same category as the Boeing 707X and the Airbus A350-1000, the biggest, most prestigious, most profitable segment in commercial aviation. And paired with it, at least in ambition, is a next-generation engine sometimes referred to as the CJ3000, aimed at the roughly 45-ton thrust class that currently belongs almost exclusively to a handful of engines like the GE9X and the Rolls-Royce Trent XWB. Now, before we go any further, it's worth being upfront about something, because a lot of coverage of this story blurs a line that actually matters. The C939 is real, and it is genuinely being worked on. The engine ambitions behind it are also real, but not everything attached to this story carries the same level of confirmation. And understanding where the solid ground ends and the speculation begins is actually the most interesting part of this whole picture, because it tells you a lot about how China's aerospace strategy actually works layer by layer, rather than headline by headline. So let's build this up properly, starting with the part of the story that is the most solid and the easiest to verify, because it's also the part that explains why anyone is taking a Chinese wide-body jet seriously at all. For more than 50 years, commercial aviation above the regional jet category has essentially been a two-player game. Boeing and Airbus didn't just build airplanes, they built entire ecosystems around them, spanning production lines, global certification frameworks, worldwide maintenance networks, financing arrangements, and, maybe most importantly, decades of accumulated trust from airlines that have to bet their operations on an aircraft type for 20 or 30 years at a stretch. Once an airline commits to one of those ecosystems, unwinding that commitment is enormously expensive, which is exactly why the duopoly has been so difficult to crack. It was never really just about building a competitive airframe. It was about matching the reliability data, the global support infrastructure, and the sheer institutional confidence that took Boeing and Airbus half a century to accumulate. Plenty of manufacturers have tried to chip away at pieces of that market over the decades. Almost none have managed to build a genuine third option at the top end of it. China's approach to this problem has not been to try to leapfrog straight to the top. It's been to climb there methodically, one aircraft program at a time, each one building the institutional muscle needed for the next. The first real step was the ARJ-21, a modest regional jet that was never really about market share. Its real purpose was to teach COMAC, China's state-owned aircraft manufacturer, how the entire commercial aviation process actually works from the inside: design, manufacturing, certification, and long-term product support. That's a genuinely difficult thing to learn, and the ARJ-21 gave Chinese engineers a working laboratory to learn it in before anything more ambitious was attempted. The next step up was the C919, a narrow-body jet built to go head-to-head with the A320neo and 737 MAX, the single most competitive and highest volume segment in the entire industry. This was a real leap in ambition, moving from learning the system to actually competing inside it. And on the numbers, it's working better than a lot of outside observers expected a few years ago. By mid-2024, the C919 program had already secured nearly 1,000 firm orders according to fleet data, tracked by Cirium, with roughly another 700 aircraft covered by more tentative agreements, and deliveries, while slow to ramp, have continued to expand beyond the launch customer. It's still overwhelmingly a domestic Chinese story rather than a global one, and it still depends heavily on Western-built engines for now, but as a proof that COMAC can design, certify, and manufacture a genuinely competitive narrow-body jet, the C919 has done its job. From there, the roadmap moves into genuinely new territory, the wide-body segment. COMAC's current wide-body program is the C929, a long-range aircraft in the 250 to 320-seat class aimed squarely at the Airbus A330neo and the Boeing 787. It was originally conceived as a joint venture with Russia's United Aircraft Corporation under the name CR929, but tensions between the two partners and the weight of international sanctions on Russia led COMAC to continue the program independently starting in 2023. This is where the technical difficulty ramps up sharply compared to a narrow-body jet. Longer range requirements, more advanced structural and aerodynamic demands, and critically, an entirely different class of engine. And this is where the engine story actually starts, because it's worth understanding that China's aviation ambitions have always run into the exact same wall, regardless of which aircraft program you're looking at. You can design an impressive airframe, but without a competitive domestic engine, you don't actually control the performance, the cost structure, or the long-term independence of that aircraft. The airframe is only half the equation. The engine is arguably the more strategically important half because it defines the operating economics, the maintenance burden, and the ceiling of what the aircraft can ultimately achieve over its service life. China has been working on that problem in stages too, and the naming convention actually tells the story on its own. The first domestic engine in this family is the CJ1000A, developed by the Aero Engine Corporation of China, AECC, through its Shanghai-based Commercial Aircraft Engines division. It's designed as a domestic alternative to the CFM LEAP 1C currently powering the C919, sitting in a thrust range up around 28,000 to 30,000 pounds. The first prototype assembly wrapped up back in December 2017, with the engine's first test run following in May 2018, and flight testing on a GN Y-20 testbed aircraft began in March 2023. Progress since then has been steady but genuinely slow by the standards of the industry. As of a March 2025 update from AECC, development was described as progressing well, and an executive from one of the C919 suppliers said the following month that the engine would soon be ready to power verification flights on an actual C919 airframe. Even so, an aviation data analyst commented in January 2026 that Chinese certification and initial deliveries of the CJ1000A are likely to begin only in 2027 or 2028, with genuine mass production not expected until around 2030. That's roughly a full decade from first prototype run to real-world fleet use, and this is the smallest, least demanding engine in the whole family. It's a useful reminder that even the first rung on this ladder has taken the better part of 10 years to climb. It's also worth understanding just how different the CJ1000A actually is from the WS-20, a separate engine China already uses on its Y-20 military transport aircraft. Before AECC committed fully to the CJ1000A as the C919's future domestic engine, there was genuine internal debate about simply adapting the WS-20, a proven military power plant already in service, rather than starting a dedicated civil engine program from scratch. The eventual decision to build a purpose-designed civil engine instead says something about how seriously China is treating the distinction between military and commercial aerospace standards. A military transport engine doesn't have to satisfy the same fuel efficiency targets, noise regulations, or decades-long reliability expectations that airlines and civil aviation regulators demand. Building the CJ1000A as its own dedicated civil program, rather than repurposing existing military hardware, was the harder and slower path. But it's also the only path that produces an engine airlines elsewhere in the world could ever plausibly trust. The next rung up is the CJ2000, sized for the wide-body C929, and this is where the recent headline number comes from. In January 2026, Chinese state media and industry watchers reported that a CJ2000 test engine had produced 35.2 tons of thrust during ground testing, a figure that puts it in roughly the same class as the GNX-1B currently powering the Boeing 787 and comparable to Rolls-Royce's Trent 1000. That's a genuinely significant result because it's the first time a domestic Chinese engine test has landed squarely inside the thrust class used by an actual, currently flying wide-body jet, rather than a smaller narrow-body engine. Even so, the honest assessment from analysts following the program is that an operationally ready CJ2000 is unlikely before 2030, which would roughly track with the C929's own expected development timeline. So that's the confirmed, verifiable part of the ladder. CJ1000 for the narrow-body C919, CJ2000 for the mid-size wide-body C929. Both real programs with real test data, both running years behind their original announced schedules, both still years away from actually entering commercial service. Now here's where the story gets murkier, and where it's worth being honest about the difference between an official program and internet speculation. The idea of a CJ3000, a next engine in the family, sized for something even bigger than the C929, in the 40-plus ton thrust class needed to power a genuine 777X or A350-1000 competitor, shows up regularly in Chinese aviation enthusiast circles and in a wave of English-language YouTube content built around the C939 concept. What's much harder to find is an actual confirmed AECC program document, an official designation, or a verified test result attached to that specific name, the way there is for the CJ1000 and CJ2000. That doesn't necessarily mean nothing is happening behind the scenes. China's military and civil aerospace programs are notoriously opaque until Beijing chooses to confirm something publicly, and the jump from a 35-ton test result to a 45-ton production engine is exactly the kind of gap that internal unannounced development work typically fills before an official name ever gets attached to it. But it does mean that specific number and that specific engine name should be treated as a reasonable extrapolation of where the roadmap is heading rather than a confirmed program with its own test data sitting on the record today. That distinction matters if you actually want to understand this story rather than just repeat the most exciting version of it. There's a broader pattern here worth naming directly, because it shows up constantly in how Chinese aerospace developments get covered in English language media, especially on YouTube. A single ground test result, a leaked internal document, or a state media social post gets picked up, stripped of its caveats, and repackaged as confirmation of a finished operational capability. The 35.2-ton CJ2000 thrust figure is a real, meaningful data point, and it deserves attention. But a single ground test at peak thrust tells you almost nothing about an engine's fuel burn at cruise, its reliability across thousands of operating hours, its behavior in icing or bird strike conditions, or its actual cost to manufacture and maintain at scale, all of which are exactly the metrics that determine whether an engine is airline ready rather than just laboratory impressive. The gap between a headline-grabbing test number and a certified commercially deployed engine is where most aerospace programs, in every country, actually spend the majority of their development time. Treating a strong test result as the finish line rather than a milestone is how stories like this one end up overstated in one direction just as often as they get dismissed too quickly in the other. Which brings us to the aircraft that would need an engine like that in the first place. Reports citing the South China Morning Post first surfaced in May 2024, describing preliminary design work underway at COMAC on a new wide-body concept referred to as the C939, envisioned as a high-capacity, long-range jet seating somewhere around 400 to 500 passengers, with a range of roughly 7,000 nautical miles, or about 13,000 kilometers. That range in passenger capacity places it squarely in the territory currently occupied by the Boeing 777X and the Airbus A350-1000, the very top of the wide-body hierarchy, the aircraft airlines use for their flagship long-haul routes. COMAC itself, when contacted directly about the reports at the time, declined to comment and asked observers to simply wait for official confirmation, which tells you something on its own about how early stage this program actually is. And that's really the key thing to understand about the C939 as it stands today. It is not a prototype. It is not even close to a prototype. Industry analysts generally describe it as existing primarily as a strategic roadmap placeholder and an advanced feasibility study rather than an active development program with a committed timeline, with development explicitly described as contingent on the C919 continuing to mature and on COMAC actually resolving the technical challenges still facing the C929. Realistic estimates for when an aircraft like this could actually enter commercial service put the timeline somewhere in the mid-2030s to 2040s. And even that assumes nothing goes wrong along the way, which, in the history of large aerospace programs, is rarely a safe assumption. In other words, the C939 sits at the very top of a pyramid that is still being built from the bottom up. And every layer underneath it, the C919's engine independence, the C929's wide-body experience, the underlying engine thrust class, still has years of work left before the foundation is solid enough to support what sits on top of it. Look at the C929 for a preview of exactly how much slippage tends to happen along the way. When the program was still a joint venture with Russia, under the CR929 name, the original plan called for a domestically developed engine, a joint effort between Russia's United Engine Corporation and China's AECC, to be certified by 2027. That partnership dissolved, the timeline reset, and COMAC is now pursuing the CJ2000 alone, with realistic estimates for an operational engine pushed out toward 2030 at the earliest. Still years past that original target, and with the aircraft itself not yet in service. If the C929, a full rung below the C939 on this ladder, and one that has been actively worked on for well over a decade, has already slipped that far past its early projections, it's a reasonable bet that whatever timeline eventually gets attached to the C939 will move at least as much, if not considerably more, once the program moves from a feasibility study into active engineering. So why does any of this matter if the flagship aircraft itself is still a decade or more away, sitting mostly on paper? Because the roadmap as a whole is not really a story about one aircraft. It's a story about a deliberate, sequenced industrial strategy. And that sequencing is exactly what makes it different from most of the challengers that have tried and failed to break into this market before. Each program in the chain, ARJ21, C919, C929, and eventually C939, exists to solve a different piece of the same underlying problem, reducing dependence on foreign suppliers while building the specific institutional experience needed for the next, harder step. It's not a single moonshot aimed at unseating Boeing and Airbus overnight. It's closer to compound interest, where each program banks a little more manufacturing depth, a little more certification experience, and a little more supplier independence. And that accumulated depth is what eventually makes the next harder program possible at all. The engine side of that strategy carries an extra layer of significance that's worth sitting with for a moment, because it goes beyond simple self-sufficiency. Historically, the largest wide-body aircraft needed 4 engines to generate enough total thrust to get airborne and cruise efficiently over intercontinental distances. Modern high-bypass turbofan technology changed that math, allowing twin-engine wide-bodies to do the same job with half the engines and meaningfully better fuel efficiency, which is exactly why aircraft like the 777X and A350 replaced older 4-engine designs like the 747 and A380 at the top of long-haul fleets. If China's engine program can actually deliver a domestic power plant in that 40-plus ton thrust class reliably at production scale, it doesn't just make the C939 possible on paper. It removes the single biggest external dependency sitting underneath the entire COMAC product line, because engine access has historically been the one piece of this puzzle that foreign suppliers, and by extension foreign governments, could use as genuine leverage over China's aerospace ambitions, the way sanctions have already been used against other countries' aviation programs elsewhere in the world. But that leverage question is not hypothetical either. During the more recent rounds of trade tension between the United States and China, there were real moments where American officials floated restricting CFM LEAP engine deliveries to COMAC as a point of pressure, tied to China's broader inclusion on sanctions-adjacent lists. Those restrictions never fully materialized, and engine deliveries for the C919 continued, but the mere fact that the possibility was raised at all is exactly the kind of scenario that gives China's domestic engine programs their urgency. An aircraft manufacturer that depends entirely on a foreign supplier for the single most critical component on its aircraft is, in a very real sense, only as independent as that supplier's willingness to keep shipping parts. That is precisely the vulnerability COMAC's entire engine roadmap from the CJ1000 all the way up toward whatever eventually powers the C939 is designed to close. There's a comparison worth drawing here to a very different aviation story that's been unfolding at the same time, because it illustrates just how much harder China's version of this challenge actually is. Russia has spent the last several years racing to build a fully domestic engine for its own regional jet program, the PD-8, after Western sanctions cut off its previous French-partnered engine supplier overnight. That program has moved from launch to certification in a genuinely fast timeline, but it was solving a comparatively contained problem. An 8-ton class engine for a 100-seat regional aircraft, built on decades of dormant Soviet-era turbofan design experience that only needed to be reactivated rather than invented from nothing. China's challenge with the CJ family is a different order of magnitude entirely. It isn't reactivating old expertise, it's building an entirely new domestic, high-bypass turbofan lineage from a much thinner starting base of civil engine experience, and doing it across multiple thrust classes simultaneously, from the 28,000-pound CJ1000 A up toward whatever eventually has to produce close to 100,000 pounds of thrust for a true 777X class competitor. That's not a knock on the ambition. It's a useful reminder that China is building its own jet engines and Russia is building its own jet engine. Describe two very differently sized mountains, even though the headlines covering them often sound almost identical. Now, does any of this mean Boeing and Airbus should be nervously watching their backs today? Not really, and it's worth being honest about that too. The C919 is still overwhelmingly a domestic aircraft, flying almost exclusively within China with a handful of operators, and it still leans on Western engines for the version currently in service. The C929 is still years from entering commercial service, and still needs its own engine to mature well beyond a single impressive ground test. And the C939, the aircraft actually built to compete directly with the 777X and A350-1000 at the very top of the market, remains, by COMAC's own conspicuous silence, and by most independent industry analysis, a feasibility study rather than a funded scheduled program with a target service date anyone can point to with real confidence. But here's what actually makes this worth paying attention to, and it's the same lesson that keeps showing up whenever a country decides to build aerospace capability entirely on its own terms rather than through the normal channels of international supplier relationships. It is genuinely difficult to build a modern high-bypass turbofan engine from scratch. It requires mastering metallurgy, precision manufacturing, decades of accumulated failure data, and a certification apparatus that Western manufacturers spent half a century building. China has now demonstrably closed a meaningful part of that gap on the smaller end of the family, with a narrow-body engine deep into flight testing and a wide-body class engine already producing thrust numbers that sit in the same neighborhood as engines currently flying on real 787s. Whether that trajectory actually continues cleanly up to the 40-plus ton class needed for a true long-haul flagship jet is the real open question, and it's one that won't be answered by a single test result or a single leaked design document. It'll be answered the same way it always is in this industry, slowly, over years of flight testing, certification campaigns, and eventually actual revenue service. What's genuinely new here, though, and what separates this from decades of previous attempts by other countries to crack the Boeing-Airbus duopoly, is the scale of the ecosystem sitting behind the effort. China's domestic aviation market is one of the largest and fastest growing in the world, backed by long-term state industrial planning, an enormous sustained investment that most challengers in aviation history simply never had access to. That combination means COMAC doesn't need its early aircraft to be perfect competitors on day one. It needs them to be good enough to fly, good enough to gather real operational data, and good enough to keep improving with each iteration, while a massive domestic customer base keeps the production lines running and the institutional experience compounding in the background. That is exactly the model China used to climb the ARJ21 to C919 ladder. And it's the same model underpinning the climb from C919 to C929 to, eventually, whatever the C939 actually becomes once it moves off the feasibility study slide deck and onto an actual engineering drawing board with a funded timeline attached. So where does that leave the bigger question hanging over this whole story? For 50 years, choosing a wide-body jet at the top end of the market has effectively meant choosing between two companies headquartered on two continents, both Western. If China's engine program actually closes the remaining gap between a 35-ton test result and a genuine 45-ton production power plant, and if the C939 makes the leap from feasibility study to funded program somewhere over the next decade, the practical effect isn't that Boeing and Airbus suddenly lose their existing customers overnight. It's that, for the first time in half a century, long-haul airlines planning their next-generation fleets might actually have a third name on the shortlist, and even the credible possibility of that third option is enough to start shifting how the other two negotiate pricing, financing, and delivery slots on some of the most profitable routes in the entire industry. That shift, if it happens, won't arrive as a single dramatic headline. It'll arrive the way the rest of this roadmap has arrived so far, quietly, one incremental engine test, and one design milestone at a time, until one day the comparison everyone's making isn't Boeing versus Airbus anymore, it's Boeing versus Airbus versus COMAC. Whether that day is realistically a decade away or considerably further out than that is exactly the debate worth having. And I'd genuinely like to know where you land on it in the comments.